in Unit 5, okay, so that's what we're starting today is Unit 5. Okay, we're going to be looking at triangle similarity. Okay, so before we actually get into triangle similarity, we need to do a little, guys, I need the side conversations to stop. Y'all go ahead and close those laptops. You do not need those open now. And you need to be following along and focusing on the lesson and taking your notes. Just close the laptops. Thank you. Okay, so before we jump into triangle similarity, we need to talk about some things, some like prerequisite knowledge that you need to have. And one of those is scale factor. Okay, so scale factor, okay, when something is drawn to scale, okay, a lot of times we say image not drawn to scale. Okay, and things can be drawn to scale. That means that it is representing the actual proportions of whatever is drawn, right? Okay, it's drawn to the actual size and proportions. Okay, so you can scale things up and scale things down, but they keep their proportions. Does that make sense? Do y'all understand what I'm talking about when I say scale? Okay, so with scale factor with coordinate points, our scale factor you can think of as your multiplier. Okay, so if your scale factor or your multiplier is greater than 1, you're going to be scaling up. You're going to be enlarging the image. Okay, if your scale factor is less than 1, you're scaling down. Okay, you're reducing the size of an image. Okay, so for example, if I want to keep these fractions or identify these scale factors as an enlargement or a reduction, I'm just going to say E or R for enlarge or reduce. Okay, so if my scale factor or my multiplier is 3/2, is that going to enlarge the image or reduce the image? Enlarge, because it is greater than 1. If I scale it by 1/2, what am I doing? I am reducing the size. If I scale it by 3/4, what am I doing? Reducing the size. And if I scale it by 5/2, I'm enlarging the image. So I just want to know, is it an enlargement or a reduction? Okay, that was pretty basic. Now here are coordinate examples. Okay, if we have coordinates, in this case, -410 and -215, and they tell us they are dilated by a scale factor of 2. So first of all, dilated, dilation is a type of transformation. Okay, it's a change happening to our image. You've heard that word dilate before? Okay, so that is just using, that is the type of transformation that enlarges or reduces the size of a shape, but it keeps it proportional. Okay, so when you see dilated, just know we're scaling it up or down. Okay, so it's dilated by a scale factor of 2. So is this going to be an enlargement or a reduction? Okay, so a scale factor of 2 tells me this is an enlargement. Okay, what are the new coordinates? So scale factor, we said up here means what? Multiplier. So we are simply going to multiply by that scale factor. Okay, so we're going to multiply our x and our y values by 2. So we are, in this case, doubling. Okay, so multiply everything by 2. Now, I know not everybody needs to show this work, but again, for the sake of your notes, when we're first learning something, I'm going to show you all the work. So I'm going to take that point, -410, and I'm going to multiply both the x and the y by 2. So what does that give me for my new point? -820 is the new point. And then I'm going to take that other one, -215. I'm going to do the same thing. I'm going to multiply both the x and the y by 2, which is going to give me what? -430. Okay, so the new coordinates are here. I'm going to highlight just to show you, to keep it, we went from here to here, and we went from here to here by multiplying by our scale factor. So far, so good? Okay, so when you have an integer value for your scale factor, it's pretty easy. You just multiply by that number. Okay, sometimes it's a little tougher when it's a fraction. So in number 2, we're dilated by a scale factor of 3/4. So is this a reduction or an enlargement? This one is a reduction. Okay, so we are going to reduce the size to 3/4 of the original size, right? So it's going to be 75% of the original. Okay, so we are, again, scale factor is the multiplier. So we are simply taking our coordinates, both the x and the y, and multiplying by the scale factor. Okay, so I am taking 3/4 of both of those values. If you struggle with fractions, when you multiply an integer by a fraction, you're multiplying the numerator by the number. So 5 times 3/4, we're just doing the 5 times 3, and then it's all over 4. So that becomes 15/4 for the x, and then 6 times 3 over 4 will become what? 18/4. Now, if you can reduce, you want to reduce. If you prefer to work with decimals, why won't my pen work? You can absolutely give this as a decimal, unless you have to round it. We're not going to round. We want exact values. Okay, but you could give these as decimals. So if you prefer to do times 0.75 instead of by 3/4, you could have multiplied these in your calculator by 0.75. And as a decimal, this would have been 3.75 and 4.5. Okay, so either one of those is acceptable for that first one. So let me just show. We went from here to here or here, whichever one of those you prefer. Okay, now we still have to do the second point. So the second point is -2 over 12. And again, I'll just show this one multiplying by the decimal. So you can multiply by 0.75 if you prefer to do the decimal. So that would give me -1.5 and +9. Gentlemen, can you please stop your side conversations? Thank you. Okay, so fraction or decimal, whatever you prefer is fine. Okay, now in number 3, they give you point A and point C, or point A, B, and C, excuse me. And then they say that these points are dilated, and then they give you a dilation rule instead of telling you a scale factor. So that means that the X and Y are not using the same scale factor. The X has a scale factor of 4, and the Y has a scale factor of 2. So we just have to pay attention when we have a rule like this, because it changes what we're multiplying by. So I'm going to list them out like this. And then they said that X is by 4. So all of my X's are going to be multiplied by 4. But all of my Y's are going to be dilated or multiplied or scaled, whatever terminology you prefer, by 2. So it's an enlargement of both the X and the Y, but the X is being enlarged more than the Y. Okay, so then my new A, B, and C. Do y'all remember when you originally learned transformations? Y'all put that little apostrophe for the new point. Did y'all did or did not do that? Some of y'all remember? That's called, we read that as prime. So the pre-image, the original point is at A. So the new point A, we have to show some sort of change because we can't just call it A also. That'd be quite confusing. So we call it A prime. So that's like the new A. So that's what that apostrophe is. Okay. So my new A, my A prime, will be at 8, 6. Okay, my B prime, my new B, will be at -4, -10. And my C prime, or my new C, will be at 1620. You feel okay about that? Okay. All right, last one on the front, we've got point A and B are located 4, -10, and 2, 3. As a result of a dilation, endpoint A prime, okay, so that little apostrophe there is read as prime again. So A prime, and they give us the new coordinates, and they want to know what the coordinates of B prime would be. So instead of telling us the scale factor, they give us the original point and the new point, and we have to figure out the scale factor and then apply it to point B. Yes? Does everybody understand that that's what we have to do here? Okay, so let's look at this. From A to A prime, we want to know what happened. Now, when I say what happened, I'm talking about scale factor, and scale factor is multiplication, right? What did we multiply by? So if I'm trying to figure out going this way, what did I multiply by? What's the opposite if I'm going backward? So you could simply, a lot of you see it without having to think of it this way, but what you're doing going backward is dividing to figure out that scale factor. So you take your new image divided by the pre-image and get that scale factor, okay, which I think almost everybody here can see that that's a 4. Okay, so our scale factor is 4 for both the X and the Y, right? It's the same for both. Okay, so this is a scale factor of 4 that I've identified. So now I'm going to apply that scale factor to B. So B prime would be where? Very good. All right, we feeling okay about scale factor? Okay, given coordinate. Let's look at some images on the back then. Okay, so when you have a pre-image and an image, okay, so a pre-image is what you start with, and then an image is what you end up with, the new image, okay? We don't necessarily know which is which here. They didn't tell us. It's not always left to right. So we're just going to reference this. I'm going to call them big and small. Okay, so I've got the same trapezoid shape. I've got a big version and a small version. Okay, if you are asked to identify your scale factor, which it didn't tell you in words here, so I'm going to add those. Just find the scale factor. That's what we're trying to do here. Okay, so if we want to find the scale factor, I'm going to have to go in both directions, big to small and small to big, and I'm going to give both because I don't know which is the pre-image and which is the image. So let's do small to big. Okay, we have to identify the scale factor. And so like I just said, when we had the point on this last one, I said when you're trying to identify the scale factor, if you're going backward, you divide because that's the opposite of multiply. So if I'm trying to figure out the scale factor from the small to the big, I actually need to do the big divided by the small, right? Okay, so this would be big divided by small. Now I can choose any of the coordinating or corresponding sides to do this, but it shouldn't matter which ones because if it's consistently dilated, all of the scale factors should be the same, right? So I could look at the tops, I could look at the right, I could look at the left, or I could look at the bottom. It should not matter. They should all give me the same scale factor. So if I look at the top and I do the big is 10 and the small is 5, that should be the same as if I do the bottom or the right or the left. Do y'all see how those are all equal? What do they all come out to? 2. So it is a scale factor of 2 if you are going from small to big. Yes? Okay, so from small to big, we have a scale factor of 2. But in reverse, if I wanted to go from the big to the small, it would be the reciprocal. What's reciprocal mean again?
Like
you flip that fraction, right? So it'd be half instead of 2. Now, if you don't make that connection or you hadn't done this work first and you were just told find the scale factor to go from the big to the small image, you would just do the small divided by the big, which you would just do the reciprocal. Like I said, you would flip all of these. You would be doing 5 over 10 or 8 over 16 or 7 over 14. Okay, and it would be the reciprocal, which is 1/2. Does that make sense? Okay, so when you are going from one image to the other, depending on the direction, those scale factors will be reciprocals of each other. So far, so good? All right, so on this last one, if you are given a graph, okay, we've got 2 images here, and notice the larger one, do you see how they have the little apostrophe, the little prime markings? So that means that that's the new image. So you go from the small image to the big image because of those prime markings. We do know in this one. Okay. So I'm going to put a note here because you've got some options when you have a graph. Okay. So you can count the altitude or base. Okay, so that's one option. Now you cannot count diagonal lines. Okay, altitude and base, that's vertical and horizontal. Remember, they're perpendicular. So you can count up and down and left and right. Okay, so in these triangles, the only thing that I could count is this side AB, right? It's the only horizontal one. There's no vertical. So I could either count the lengths of A to B and do it that way, but you cannot count diagonal lines. Okay. So you choose a horizontal or vertical line, or vertical side, I should say, to count. Okay, so like I said, in my case, in this specific example, the only horizontal or vertical is A to B. Okay. So that's what I'm going to count in both of these, in both the pre-image. So from A to B, that's 1, 2, 3. And from A prime to B prime, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this one didn't tell us in words to go from small to big, but I can tell based on those markings that this is prime, that that's the new image. So I know it's small to big. Okay, it's triangle ABC to triangle A prime, B prime, C prime. Those prime markings is why I know that's the new image. Okay, so if I want to go from small to big, I divide big by small, right? Is that what we said? So that would be 9 divided by 3, which is 3. So that is the scale factor of this dilation. Yeah. We feel okay about that? So finding scale factor, you divide. Given scale factor, you're multiplying to get to the new image. Yes? Okay. So you have a practice assignment. I don't have it linked in the module or the calendar yet. I'll work on that. But if you go to your actual assignment list in Delta Math, or sorry, in Canvas, you should see the Delta Math. It is dated. It has today's date and says 5.1 practice. Okay, so that's what you should be working on.